Let us look at the unit circle and the graph of the tangent function. Tan theta is equal to n, all right? And we're going to see what angles will yield a certain value when you find the tan of that angle. All right, so you know that this circle is divided into 4 quadrants. The first quadrant, second quadrant, third quadrant, fourth quadrant. And the first quadrant is between 0 and 90 degrees. Second quadrant, 90 to 180 degrees. Third quadrant is between 180 and 270 degrees. Fourth quadrant is between 270 and 360 degrees. All right? 360 degrees, one complete revolution. Now, remember, the tangent of an angle, opposite divided by the hypotenuse. Remember that it applies to right angle triangle, right? So suppose we consider this triangle here. So we have this angle. Oh, opposite over adjacent, I should say. Is the opposite over adjacent for tangent, all right? So here now, let's call this angle theta. This is our theta. The tangent is the opposite divided by the adjacent. Now, here, what other angle will give us opposite over the adjacent equal to this one? All right. Suppose we draw a triangle in a similar triangle there in the second quadrant. Now, what we see is that the opposite here, this opposite divided by this adjacent will be a negative, because while the opposite goes upward, it's positive, the adjacent runs to the left from the center. It's negative. We're going to see that later on. So let us use this triangle then and see what will happen. This opposite is negative, this adjacent is negative. So I expect that the tan of theta, this angle here, the tan of this angle, will be the same as the tan of, if you pass 180 and go theta more, you get this, will be equal to the tan of 180 plus theta. We're going to test it. We will test it later. Now suppose you have a triangle in the fourth quadrant. This opposite is negative. The adjacent is positive. It runs to the right, so this will be a negative value. All right? So, if you find the tan of this angle between 0 and 90, the principal angle, I expect that you get a positive value. And when you find the tan of the angle, 180 plus the same theta here, you get a positive angle. If you find it at 180 minus theta, that's in the second quadrant, it's going to be negative. If you find the angle 360 minus theta, that's in the third quadrant, it's going to be negative. So, want to try? We'll do that, and then we later on will come to using the graph of tan theta. So, what is the tan of 30 degrees. Let's see if we can get our calculator to give us that answer. We're going to find the tan of 30 degrees. My. So, we're in degree mode. Tan 30 equal 0.577. All right. So 0.577. Now, suppose we find the tangent of 180 minus 30. I can be confident that it will be the same 0.577, but it will be negative. The reason it will be the same is because this triangle is similar to this triangle. Same sides, same angle, right here. But it's in the second quadrant. Now, the original triangle, this one, the opposite is positive, adjacent is positive. Positive opposite over positive adjacent give you a positive 0.577. What will happen here? This angle, same length of opposite, same length of adjacent, but the opposite is positive and the adjacent is negative. So it will be a positive opposite over a negative adjacent, which will give you a negative 0.577. Let us now try it. Tan of 180 minus 30. Because remember, we're going 180, then we're backing off 30. So we come to this angle. 180 minus 30 is what? 50, 60, 70, 80. Which is tan of 150. Now, what is the tangent of 150? Let us see. Tangent of 150 equal negative 0.577 as expected. All right, equal negative 0.577. Now, what about the one in the third quadrant? For that one, you'll have to go 180 and then go 30 more to line up with this triangle. This triangle is similar to this triangle. All of these four triangles are similar, right? But let us see what happens here. Tan of 180 plus 30, which is going to be tan of 180 plus 30 is what? 210. I expect it to be positive 0.577. So let's check it out. All right. So the tangent of 210 equal positive 0.577 as expected, 0.577. All right. Now, if we come to the fourth quadrant, we're going to find the tangent of 360 minus 30, which is the same as tan 330. How do I get that? Because remember, you're going from here, go all the way around 360 degrees, then you back down 30. 360 degrees is 330 degrees is the same as negative 30 degrees. But remember, positive angles are measured in an anti-clockwise direction. Alright? So, the angle that we're really finding here for the 330 is this. If you go this way, it would be a negative 30. but this way is a positive 330. Alright? So, I expect that the tangent of 330 will be a negative 0.577 because the opposite goes down from 0, is negative. Adjacent goes to the right from 0. It's positive. A negative opposite over a positive adjacent. Negative divided by a positive give you negative. So I'm expecting a negative 0.577 here. So let us see the tangent of 330. Tan 330 equal negative 0.577. Alright? So it's negative 0.577. Alright. So that means if you were asked to find the tangent, the angle such that tan theta is equal to 0.577, you would have found two angles so far. You would have found 30 and 210. Right? So theta would be 30 degrees. You also found 210 degrees. What would be the other angles? Well, here, if you weren't told where to stop finding angles, you could find an unlimited number of angles, because to get right at this point, you could go all the way around 360 and then 30 more. So another angle would be 360 plus 30, which is what? 390. Is the tangent of 390.577? Let us see. So we want to find the tangent of the angle 390. That equals 0.577. 390 works. What's the next angle that it would happen? Well, if you start here and go all the way around to 360, then you go 180 more, that's 360 plus 180, then you go 30. Alright? Remember, you know, the angles where you get the same value are in the first and the third quadrant. So you go 360 plus 180 plus 30. Let's see how that would go. So the next angle is 360 plus 180 plus 30. What would you get? 0, 8, and 6. What about 14, 15, 17? Bring down the 7, carry 1. 3 and 1, 4 and 1, 5. 570. So I expect I expect 570 to be another angle. When you find the tangent of it, it gives you positive 0.577. Let us try it out. So, the tangent of 570 equals 0.577. And you could go on and on and on. Right? You could go on forever finding angles. But you would be asked to find the angle theta such that theta is between 0 degrees and 360 degrees. You would have found two of them, the 30 and the 210. You don't want to pass 360 degrees. Alright? If you're working in radian mode, this is theta. If you're working in radian mode, it will be between 0 and 2 pi radians. Alright? Remember, one complete rev contains 360 degrees, which is the same as 2 pi radians. Circumference is 2 pi r. Alright? It's 2 pi radians. 360 degrees equal 2 pi radians. What would be the 30 degrees and the 210? If it was in radian, you would have put your calculator in radian mode. But if you want to convert from radian to degrees, let us do that quickly. 30 degrees equal, we don't know how many radians. However, we know that 360 degrees is equal to 2 pi radian. We divide by 360 to get 1 degree equal 2 pi over 360 radian. Multiply the 1 by 30 to get 30, so 30 degrees is 2 pi times 30 over 360 radian, and you work that out. For the 210 degree, it will be 2 pi by 210 over 360. Alright, so we found these are some of the angles using the thing there, the unit circle. Now, what about the graph? I see something here. We have our graph plotter here, GeoGebra. Now, this graph is showing numbers on it, which would be more appropriate for radian measure. All right. Well, let us see the graph of tan x. There you go. That's the graph of the tangent of x. Let me make it thicker. All right. So the graph of tangent x. Right out here would be 2 pi, the same as 360 degrees. Now, how you get this graph, remember, the opposite divided by the adjacent is what you plot to get these graphs. If you should plot the opposite over the adjacent for a certain triangle, you will find that, well, for a right angle triangle, as this angle gets larger, the theta gets larger, the opposite gets taller. The adjacent remains the same. Alright? The opposite can go all the way to the stratosphere, as they say. So as this opposite gets taller and this adjacent remains the same, you get the answer get larger, and then the theta, it gets closer and closer to 90. The answer opposite over adjacent, the opposite will get taller and taller and taller as this angle approaches 90, but the adjacent will remain the same. So you have these lines go up to positive infinity, these go down to negative infinity. Now, here, if you should have something like this, right? You're going to draw a line across. What would happen? You would have, for example, 30 degrees. Tan 30. 30 degree. If you were doing this in thing there, in degrees, this would be 180, 90, 30 degrees, somewhere about here, right? And you would have a point going up to the curve. Then from that point you project horizontally. Project a line horizontally. It would cut at 30. Then it would cut at, this would be 180 plus 30. Right? 180 plus 30. See the correspondence? And it would cut at, this would be 360 plus 30 more. Right here. So you go 360 and 30 more, end up at the same place here. So it goes on and on like that. Alright? So you could use a graph or you could use a unit circle to find the angles whose tangent gives you 0.577. Alright, so what we're going to do in our next video is look at some more trigonometric functions. So I will see you then.